Hey everybody, it's Ted here. Wanted to go over today a little bit about EDC and how that works. This is the electronic diesel controls for Volvo Penta. These engines are 1990s versions, early 2000s. The engine I'm going to talk about today is exclusively the KAD or the KAMD44, and these engines are the inline 6-cylinder engines. And they are basically an engine that is turbocharged, and it is also after-cooled, and it may also, with a K, have a compressor on it. So these engines are a 4-liter engine, and there were two versions that were made, which was the A version and the B version. So the A version being the early one. I'm going to go over a little bit about the wiring and a little bit about the key switch. I can't go too far into it because it would take hours. So I'm going to try to chop these up into pieces so you can kind of see how this system works. If you're trying to work on one of these electrically, it can be kind of challenging because the way that the wiring is set up. So I'm going to go over some of that today. We're going to go over first a couple of harnesses that were used, and those harnesses, the designs of the harness and the connectors of the harness, and then a special tool that you kind of need to get the later model harnesses apart so you don't damage them. So let's get started. All right, here's a display, and here's a EDC control. It's just a mock-up we have here. And basically you have your standard cutout for your gauges, your key switch, you have your alarm, you have an alarm test button, you have your little lights here for if the alarm goes off. So the standard is for a single station, single lever control is 3 buttons. If you have twin engines, you have 2 levers here, then you would have this 6-button setup, which would be you have an active station for either side, you have your diagnostic button, your neutral buttons, and then a sync button. EDC will automatically sync if the RPMs are within a certain range, but you also can disengage them by pushing that sync button as well. Now, underneath the helm, let's kind of look underneath the helm and see what we see. All right, so a wiring harness for the helm station. The main harness plug is this large 16-pin harness plug, and that has to do with all the gauges. It has to do with the alarm. It especially has to do with the key switch, lights, and so on. The back side of your push button panels are, they're universal in the way that they're set up. They're all the same. If you ever have to take one of these apart, in other words, what's inside this is a bulb, and if there's a problem and that bulb goes out, then you may have a fault because that bulb has to have continuity to the circuit and the engine may not start. You're going to have issues with it in a certain bulb, and I'll get to that later. But if you ever have to remove this, it's pretty straightforward. All you have to do is unplug the connector, take the bulb, and twist it. So I'm going to take this one that's a little harder to get at over here. And what I want to do is twist it, and when I twist it, it pops out. And there's that tiny little bulb here, okay? And that is the push button that actually pushes in on the control, all right? And it actually pushes in and it activates this switch. Now these are universal. I can move that any place I want. The other thing to understand is they have 6 wires on them, and 2 of the wires there's a jumper here, so it jumps either side. So if you put the plug connector in upside down, it only goes on one way, but you can put it on upside down. It does not make a difference because there's a jumper here. So you can plug it in either direction. When you want to put it back in, just hold onto it and it snaps in. No big deal. The key switch, we're going to go over some of the wiring for that. That is a separate plug. So the push button panel and the remote control is a separate harness from the key switch harness. Let's look at those two now. So this is the key switch harness, and this was always the key switch harness design. It has a plastic lock on it that screws on. They get brittle. This one broke off years ago as a demo unit. And then you have your remote control. Now your remote control originally came out with the same type of harness, first generation TMD42s, I believe the KAD43s. They had this same harness, so there was 2 of these. They found that there was issues with the remote control with this harness, so they left this for only the key switch and the gauges, and then they switched over to these double-8 plugs. These are very specific plugs, and they are very, very difficult to get apart unless you have a special tool for them. These have been used over and over and over in the lab since the 90s, so, and they still work. I still use them in the lab when I teach with students and how to plug these in and how they work. So let's kind of look at the remote control and that part first, and I'll show you how that works. So for your push button panels, you have these plug connectors, and you have one of them is for your active station, one is for diagnostics, and one is for the neutral button. As you'll notice on the back side, that's that jumper I was talking about. So if you plug it in this way, or you turn it in and plug it this way, it does not matter. It works the same. This typically is up underneath the helm, and it is attached with screws and a little plastic plate. Keeps water out of here. But if you ever did take that off, what you're gonna notice is these are all labeled, which makes it very, very easy to identify. It's upside down, but neutral, diagnostic, active station. So these three go to that push button panel, the 3 push button panels. If you have twin engines, you're gonna have 5 of these, so it's a bigger connector. So here is the 3 buttons for the actual push buttons, and what I'm gonna do is I'm gonna find the first one. This one's neutral, so that one is neutral. Get it right. There we go. That's neutral. This one is active station. That's the bottom one. And again, there's jumpers, you don't have to plug it in. And then obviously the last one is for your diagnostic button. And these all just plug in like this. Now, because this is kind of open, these are susceptible to corrosion over the years. Water gets by the panel, condensation. If you have problems, replace the whole harness. Don't try to mess around with connectors or anything like that. You're just gonna aggravate yourself and go crazy. So if this is attached on the helm as such underneath the dashboard and you take this off, if you look under there, you might actually see water dripping out of here. And if you do see some discoloration, then you probably need to replace this whole harness. All right, the other end of the harness is your double-8s, and these plugs are gonna head down toward the engine. You also have a Y-split harness here, and you have 2 more connectors. One connector is a single 8-pin connector, and there is an option for a neutral safety switch. This neutral safety switch would attach to the remote control if you had a neutral safety switch built into it. It was an option, it came out later. Now, so we have the 2 harnesses that go down to the engine, and then we have this harness plug. There is an additional harness, and that is this harness. And this harness, it's very simple. You can't plug them in wrong. They only go one way, okay? And then you squeeze those together. At the other end, now what we have is we have the remote control. So now this is for the remote control over here. All right, now there's 2 harnesses here. One of them might have a tie wrap on it, and it might be tie wrap back, and it might have a plug connector, especially if you have electronic remote control. That one that has the tie wrap on it will say the gear pot, that's what it'll say. That is if you had a mechanical control with cables, you would plug this into the other potentiometer. So you would have 2 of these, one would plug into this, and the other one would plug into your remote control or other cable. So you could have a remote control with 2 mechanical levers, 2 cables, and 2 of these stacked on top of each other. And then you would plug one into one and one into the other. One would be for the gear shift, one would be for throttle. With EDC, we have the gear pot is not used. So the potentiometer, and pot stands for potentiometer. The potentiometer is not used. So all we use is the throttle potentiometer. And that's pretty easy just to plug it in. You can't plug it in backwards. It only goes in one way and snaps in. If you ever want to disconnect it, don't pull this plastic clip out. That's what everybody wants to do. Just simply push the clip in and the connector comes off. So don't pry the connector off, it'll fly away and then you'll never find it and then you can't put it back on. So that gets plugged in. And now at the other end, what we have now is we have plugged in both connectors for remote control, and we have this. And at the other end of it, what we have is we have these double-8s. Okay, so now these go down to an extension harness, which plugs in here. You can't plug them in wrong, and the other end goes down to the engine. We'll look at that in a minute. Now what I wanted to do was kind of go over the key switch harness next just a little bit and go through some of the wiring and the functionality of the key switch, because it is an electronic control vessel. There's a lot of differences between plugging into this and plugging into a regular fuel injected vehicle. So let me just go over a little bit about that with you. All right, so I have an EDC book here, and it has the harness plugs and all the pinouts and the color codes, and it gets complex. But what I wanted to do is I just wanted to go to the key switch first and kind of talk about the key switch. Now the key switch with Volvo is this plug connector. So again, it's this round plug connector that plugs into the harness, that plugs into that panel. And in that key switch, what we're gonna have is we're gonna have some wires here, and I'm gonna go over some of the wires in the plug connection. So first off, what we have is we have the actual numbers and the single letter for the key switch here. So from the engine, there is a fuse, a 7.5 amp fuse, and that fuse feeds power up to the key switch, and that wire is red. The number on the key switch is 30. So power goes into 30. So if you don't have an engine, you turn the key on and nothing happens, you know, go down to the engine, check the 7.5 amp fuse, check your battery switch, check your batteries, and then what you want to do is come up to the key switch. And you can go to the back of the key switch and you can see if you have power on that pin 30. When you turn the key on, all right, now you have continuity with 15B, and there's another one, 15A, which was for glow plugs years ago. Ignore that one. 15B is a red and blue wire, and that goes out, and basically the function of that is it wakes up the processor. So if that wire has an open in it, the processor's not going to wake up. You will have lights on the dash, your gauges will light up, things like that, but nothing else will happen. Typically when you turn the key on an EDC engine, if it is a stern drive engine, you will hear the actuation of the shift actuator. You'll hear it rack back and forth, and that will tell you that yes, the EDC processor is waking up. Now, if there's a problem with that, then obviously you can't start the engine and you have to get the trouble codes and find that out. Now, the next wire that I wanted to show you is this pin 50. Pin 50 is red and yellow, which is inverse of what we have for the United States in gasoline engines. It's yellow and red. So they use red and yellow. That is a crank command. And what that means is voltage goes into the key switch, you turn it on, the processor wakes up, and when you turn the key to crank, voltage goes down into the processor, and it is a command. That's all it is. So if it sees voltage on that wire, then it will energize the starter solenoid, the starter relay, and it will make the engine start to crank over. If it sees RPM, then it will start. There's another wire here, which is pin 19, which is only used on larger engines, the 7-liter engines. Just ignore that. The last wire I want to talk about is the S wire, and the S wire is the stop wire. That wire is violet, and that basically shuts power off to this connection. And what we have is we have kind of a multiple connection between this comes down and it goes to the processor and it goes over to the remote control. From that, we also have that wire gets open, but it also, interesting enough, supplies power to the stop solenoid, which is inside the EDC injection pump. And that shuts the fuel off to the injection pump. So that wire has to have power to the injection pump for it to shut the fuel system off. All right, next I want to talk about how we get from the helm here down to the engine, and if you have a single station or if you have multiple stations. The key switch, the round harness, you can have multiple helm stations. A lot of applications, what they have is they have a master station, which is one helm station with a key switch and the gauges, but you can add a second station. You can have another cable with a Y-split harness on this that will go up to another station with another key switch. And the nice thing about EDC is if you just have one station here and you want a remote station, all you need is the actual push buttons and you need the remote control. Now to get from here down to the engine, you have, again, these double eights. And if you simply have one station, you would plug an extension harness, and the extension harness would plug into the engine. There's 2 receiving plugs on the engine, and those would just be plugged in. If you have another station, if I have another station with another set of push button panels, then what I need is I need one of these boxes, and these are known as MS boxes or multi-station boxes. Each additional station requires, obviously, remote control, a push button panel, 3-wire, 1 for single or duals like this, and you need a multi-station box per engine, per drive line, per station. So if I add on a twin engine, if I have 2 separate stations, then I would need 2 of these at the alternate station. If I had 3 stations, I would need 1 for the first station on top of the main station, and then I would need 2 more of these for the next station. So there's a little trick when we plug this in, and you can see that there are double eights here, and this is the harness that would plug in the double eights, and that's what you would think you would do. It's different, it doesn't work like that, so I want to try to simplify it as easy as I can. So I'm going to show you a little diagram and talk a little bit about how do we plug this in, and how do we identify if this is not plugged in right. So let's do that. All right, so the trick is we have the remote control, the push button panel, and we have the double set of 8s that I showed you. Then you're going to plug into an extension harness that would go down to the engine. So this is an extension harness. So if you only had one station, you would have your key switch would have a separate harness that goes to a different plug. You would have your remote control. You could have mechanical controls that go to potentiometers, but that still is going to tie into these double 8s here. So these are double 8-pin harness plugs that are part of this harness. Then you would plug an extension harness into this, and you can't mix it up. They only go in one way. This one's male, this one's female, this one's female, this one's male. So you can't plug them in wrong. Then you come down to the engine, and it would simply plug into the engine. So the extension harnesses come in different lengths. Again, if you have problems today with dropping out, you've got an engine that does weird things, I would start looking at the harnesses first, because pin connections can be issues. A little bit of water gets in here, and it just raises havoc with the actual pin connections and the wiring. And it's hot or cold, the boat vibrates, and you're going to have, different things can happen. A lot of different weird things can happen. The engine doesn't start, won't shift. There's alarms, they come and go. So harness problems are very common in older engines, obviously. Now, if I want to add a second station, I want to put a station in here, then there's a trick to this. You need the MS box, and the MS box has 3 connectors. It has a single connector, it has the double connector, right? So you can see over here that there's the MS box, and it has the double 8s on it, and it has the single connection on it. So there's your single connection, and there's your double 8s, and it's likely going to be mounted in the boat like this under the helm or down someplace in the boat, and the double 8s are going to come down and they're going to plug into that. Now, here's the secret. As you come down from the engine, we don't think about the voltage coming down. What we always think of is the information highway always comes from the engine and goes up to the helm. Don't think about the information going down to the engine. Always just think in one direction. So whether it's EDC, EVC, it doesn't matter. The information highway is always from the engine to the helm. So here's the way you plug it in. So here's your engine, here's your extension harness, and then what we do is we say, okay, here's my lower main station. I want to unplug these connectors here, and I want to slip in on a breakout harness, and I want to put an MS box here. So then what we're going to do is unplug this harness here, and then we're going to take and we're going to put this breakout harness into it, okay? And what we do is we break into the harness here, and we plug the engine into this end. Then we continue with the double 8s to the main helm station. That's where the key switch is. Then what we're going to do is we're going to have this single little 4-wire plug, and that 4-wire plug is going to plug into the MS box.
Then from the MS box, we have these double eights, and they're going to go to the next helm. So that's the secret of how this has to work. You have to remember that if you're going to break into the main harness and add a second station, the information highway always goes to the main station first. So here is to the main station. So we're going to slip this double eight here, and we're going to take this double eight and we're going to plug it in here. So the information always goes straight to the engine, to the main station. If we want to go to another helm, we break out into the other helm. So here is the breakout. And all you need is 4 wires. It's just for the remote control. That's all it's for. So it's always heading towards the second station. Do not invert this. If you invert this and you put it backwards and it faces down, it will not work. You'll just be going crazy trying to figure out what's wrong with it. So always from the engine up, and we break out to another station, but we continue on to the remote control.
Okay, we come down to the engine with the 2 harnesses, and the 1 harness for your key switch and your helm gauges and so on is the round plug connection, and on a 44 that plugs in back here. So in this plastic box, it plugs in here. Inside this box there are fuses and there are diodes. The other control is the double eights here, and those are the plug connections that go to the remote control. So you have these 16 wires here, and you have the 16 wire plug here, and that's the 2 harnesses that have to go all the way up to the helm. If you go down onto the engine, probably where the starter is down here, I'll show you that. So power coming up to the starter solenoid here, your battery cable, and you'll have a negative battery cable here that attaches to the starter. This is an isolated system, which means that the ground cable does not have continuity with the engine at all. The only time it has continuity is when you shut the engine off, and that's another subject. Down here on the engine is your connectors, and these are the major power supplies that are going to be for your shift actuator, and you also have your 7.5 amp fuse, which is for the shift actuator power, which is for the actual potentiometer. From this point, heading up to the engine, obviously, this goes into the harness, and then it comes up here, and you have your double eights here. So being the engine is isolated, what it's called is a 2-pole system, which means that you have a completely isolated ground from the engine block. The same thing, the alternator is a very specific design alternator. You just can't go buy an alternator for this. This alternator is completely isolated internally from the ground on the block. So it has an external ground, and it has its external power supply that are going to tie into the harness. They're going to come down and attach to the starter underneath here, and that's where power is going to go to the starter. Your EDC processor is here. You have your fuel injection pump, you have your fuel filter, your oil filter, and then what you're going to have is within that injection pump, you're going to have a speed sensor, you're going to have your shut-off solenoid, and you have a temperature sensor in here. This is your return, and the fuel feed line comes into the engine here from your rake or fuel water separator to your primer pump. So it still has a mechanical primer pump, it has a mechanical pump, but that mechanical pump is electronically controlled. It is a rotary style pump, so instead of having a lever on it for a mechanical control, you actually have a solenoid inside here, which is controlled by this processor based on what the throttle lever position is. So that gives you a little overview of the electronic connections on the engine. It is an isolated engine where the processor and the harness plug is here. This is a slide lock connector. You pull the lock down, this slides off. I would not recommend that anybody goes in here unless you're an actual certified technician. Stay out of that harness. Back up here, again, there is another fuse. This is a fuse that goes to the engine, that goes up to the helm. There are 2 push button circuit breakers here as well, all right, for the system itself. Okay, here on the front of the engine is the auxiliary stop button. If you're down in the engine room as technicians, we're down here working. We can plug a remote control in, we can start the engine remotely, and we can stop the engine. All right,
Well, I hope you understand a little bit more about how the EDC platform works. These again are older Volvo Penta first electronic generation engines. And the thing about these engines you have to remember is they're early model electronic engines. There is no CAN bus information here. This is what we would call a basic serial data information highway, which means that the information here on these push buttons is just voltage. That's all it is. You're either opening a circuit and you're taking voltage away, or you're pushing on a circuit which is adding voltage to the circuit. And that voltage is being received by the processor, and then the processor makes a decision based on if it sees voltage or it doesn't. That's a whole nother video that I can do later. It might take me a little while to get to it. I've got a diesel class coming up this term that I'm going to teach, so I might just get to actually do another one for my students, and I'll share it with the rest of you out there in the real world that might own this and work on it. So the last thing to kind of in parting words here is there's a lot of wires. There's a lot of wires with this. You have 16 wires here, and you end up with 16 wires going down to the engine. So when you think about it here, you got up to 32 wires that go from the engine to the helm. And that's just for one engine. If you have twin engines, then you've got 2 sets of these. So there's a lot of wire here in their first generation engines. Really nice engines. I mean, they run well. They perform very well for their age. They're fully rebuildable, whether it's a 7-liter or 4-liter engine. They're not that complicated electronically wise. It's wiring that they're a little complicated with, but I'll go over a little bit more of the functionality of how this works and what happens when you push the buttons in a later video. So if you like the video, hey, hit that like button and please subscribe, and I'll see you in the next one.